Good morning. This is B. Naresh, working as assistant professor in a EC department. And today we are going to discuss definitions and terminology on a module 2, that is bipolar junction transistor. So in this session, we are going to observe some of the important definitions that should be covered with what are the parameters related to bipolar junction transistor. And the first one is, what is actually transistor? So here the transistor is defined from trans plus resistor. So means it transfers the from low resistance to high resistance device here. So that is the reason. A transistor is a semiconductor device which transfers a weak signal from low resistance input circuit to the high resistance output circuit. That is the reason. It transfers a low resistance circuit to the high resistance circuit, that is called as the transistor. For this case means low resistance means input side we need to offer low impedance, and to satisfy this definition at the output side we need to offer high impedance. So that is the reason a transistor is a semiconductor device which transfers a weak signal from a low resistance input circuit to the high resistance output circuit. Now define operating point. So in this case, actually in a bipolar junction transistor or in a diode, the operating point is the most important point. So means at which point the device is functioning exactly, means there is no distortions and there is no losses in that particular device. So for this case, we need to define a particular operating point. That operating point here, it is also called as a Q point. So in this case, for this bipolar junction transistor, the operating point of a device that is also known as a biasing point, and it is also called as a Q point or a quotient point, is a steady state. So under the DC low line condition, means there is a reason DC voltage or a current at a specified terminal of an active device such as a transistor with no input signal is applied. Means under that means the transistor, first we need to configure the biasing condition at which that particular biasing condition, under the absence of given AC signal, we need to find out the DC load line. At that DC load line, again we need to find out the particular operating point. So always, generally we know that the operating point is always the center of the DC load line. So that here it is called as the Q point, or it is also called as the operating point. Now the third one is, what is H parameter or a hybrid parameter? So in this case, in a bipolar junction transistor, we need to identify the analysis of the amplifier is observed by using the small signal model or a small signal analysis. The small signal model or a small signal analysis is observed by the H means. So if you observe the transistor is acts as a two-port network. The transistor is acts as a two-port network, means it contains two input parameters and two output parameters. Let us take input parameters are V1 and V2. The output parameters are I1 and I2. So in this case, if you take in a generalized transistor, so means that is represented as the collector current, and that is output current is a collector current, and input voltage. Otherwise, you can write this is V1 and I1, and this is V2 and out I2. So let us take for the transistor case, we have the input side, we are representing that V1 and I1, and output side, suppose we are representing that in terms of means output is measured in terms of voltage and current V2 and I2. So means the output current and input voltages are representing in terms of V, means in terms of I1 and V2. Means this I2 and V1 is a functioning of I1 and V2 that defines the small signal model or a H model. So hence the hybrid parameters, or it is also called as the H parameters, they are useful for describing the input and output characteristics of the circuit. So if you observe the diode contains only the two characteristics, that is forward characteristics and the reverse characteristics. Similar to that, if you consider the bipolar junction transistor, it contains two types of the characteristics, that is called as the input characteristics and another one is output characteristics. So in that input and output characteristics, we need to define some parameters like how much input impedance is output and how much output impedance is output. Then what is the voltage gain and what is the current gain. So all these parameters can be absorbed by using the small signal model analysis, that is nothing but a H model analysis, that is called as the H parameter analysis. Now define AC load line. So means this AC load line is absorbed under the presence of given AC input signal. So that is whereas the load line drawn under the conditions when an input signal along with the DC biasing means our DC voltages are applied. So while drawing this AC load line, it also intersects the Q point, that is the DC characteristics point. So that particular line is called as here the AC load line. Suppose if you take in the characteristics, so first we need to draw this in output characteristics. Suppose if I take the transistor output characteristics, so means output voltage, this is V out and output current I output. Then first we need to draw the DC load line under the absence of, so this is the line is absorbed under the absence of given AC signal, and that signal is called as the DC load line. And the center of this DC load line is indicates the bias point, or is also called as a Q point, that is also called as operating point. And the same, we need to absorb how much maximum current and the maximum voltages will occur under the presence of given AC signal. So that should be measured when we are drawing this line with respect to this Q point. That line is here, it is called as the AC load line. Now similarly, define DC load line. Just now we observed what is the DC load line. The DC load line is a load line of the DC equivalent circuit defined by reducing the reactive components to 0. And it is used to determine the current, the DC operating point, and that is called as here the Q point. Now define active region. So generally, if you are taking the transistor, means based on the transistor construction, so means it two means let's take we have that this is normal PN junction. So two PN junction diodes are interconnected back to back. Two PN junctions are connected back to back, then it is called as the transistor. So let us take, suppose this is one PN, back to back means another PN, this is P and N. So two PN junctions are connected back to back, then it forms one transistor. Hence, it contains the three terminals. One is represented as the bin. So whenever the two terminals are interconnected, that is the base. One terminal is the emitter, another terminal is the connector. Then, similar to that, if I am doing like this, two PN junctions are connected again back to back. Here, this is N, this is P and N. So this interconnecting point, here it is called as the base, emitter, and the collector. While forming this one, we have the two junctions. One is input side, another one. So this is the one PN junction, and this is another PN junction. Either here also this is one PN junction and this is one PN junction. So hence, while constructing the transistor, it forms the two junctions. So one junction is related to input side, one junction is related to output side. And most of the cases, so here we taken as, and this is called as a, if it is a common emitter configuration, this is emitter base and it is called as collector base. So this is one junction is called emitter base junction. Another one is collector base junction based on the principle. So here also whatever the transistor. And here this is emitter base junction. And if you form this one, it is called as a collector base junction. Then at this particular junction, if you want to identify the behavior of this particular device, now we need to apply the some amount of the force. Means the force is applied between either emitter base junction or collector base junction. And at this point, if you want to make this active region, so we need to follow the emitter base junction should be, means emitter junction or emitter base junction is always forward bias, and the collector junction or collector base junction should be reverse bias. Hence, if the emitter base junction is a forward bias and the collector base junction is a reverse bias, then we can say that the mode of operation is, the region is called as active region. Now similar to that, define saturation region. So again in that, so just to discuss, we have the two transistors based on this construction. This is P and N, again back to back one more PN junction. So let us take this is emitter, base, collector, and this type of the transistor here it is called as Pnp transistor. And suppose if I drive it the reverse like this, this is N, P, another P is a back to back connector, this is N, and this intersecting point is called as the base, and up emitter, and this is the cut. So this type of the transistor here it is called as NPN transistor. Now we have the two junctions. One is emitter base junction, another one is collector base junction. What is the transistor? Either PNP transistor or NPN transistor. We have the two junctions. One is emitter base junction, another one is collector base junction. So hence, in this case, if the both the junctions are forward bias, then we can say that the mode of the region of the transition region is called as a saturation region. So hence, in a saturation mode, both of the junctions, that is both of the junction means emitter base junction and collector base junction or in the forward bias, then it acts as a saturation mode. Now define cutoff region. So similar to that, so we observe the two junctions. One is emitter base junction and collector base junction. Now if both these junctions are reverse biased, then we can say that the mode of operation is cutoff mode. So hence, to define this transistor operation, we have this one. Two junctions, emitter base junction and collector base junction. Then we are defining the mode of region. If both junctions are reverse, means if I am taking like this, if both the junctions are reverse bias, the mode of region we can say that cutoff region. If both junctions are forward bias, the region is, we can say it as saturation region. If emitter base junction is a forward bias and a collector base junction is a reverse bias, the region it is called as active region. If emitter base junction is a reverse bias and the collector base junction is a forward bias, this region here it is called as a reverse active mode of region. So these are the two junctions are formed based on the construction of the transistor, either irrespective of the transistor, either NPN transistor or a PNP transistor. Now, we need to define what is the forward gain of the transistor. That forward current gain is defined as HFE in a common emitter converter. So actually, we have the four H parameter models that is represented as HI, HR, HF, and H, where HI is represented as input impedance, HR is represented as the reverse voltage gain, HF is represented as forward current gain, and HO is represented as output admittance. Then, based on the transistor construction, we have the three types of the terminals. One is emitter, base, and a collector. And based on this, we have three types of the configuration. We know that one that is common emitter configuration, common base configuration, and common collector configuration. So if you want to write these H parameters to this common emitter, we should write this is HIE, HRE, HFE, and HOE. So these are the representation for common emitter. If you want to write the common base, it should be represented as HIB, HRB, HFB, and HOB. This is for common base representation. If you want to write for the common collector, it should be represented as HRC, HRC, HFC, and HOC. So this is for common collector configuration. So based on that, now we need to define. This is called as HFE, means forward current gain in a common emitter transistor. So hence the forward current gain for the common emitter configuration is defined as, so this is current gain, means it is a ratio of output current to the input current. So here we use this common emitter configuration, means emitter is a common for input side and output side. Let us take this is the emitter, and base, so collector. Now we need to draw the common emitter configuration, means emitter is common for input side as well as output side. If emitter is a common, now the base is acts as a input and output is acts as a collector. So generally any gains is defined as it is a ratio of output parameter to the input parameter. So in this case, the output parameter is, so output, what is the output parameter in a commutator? There is a collector current. So hence the collector current is defined as IC. And it is the ratio of input parameter. What is input parameter? The base is input parameter. Hence it is defined as I. So that is the reason. It is a change in the collector current divided by the change in base current when the collector to emitter voltage, means when VCE is this collector to emitter voltage is nothing but a VC. So that we maintain as a constant. Now define input impedance HIE. Again, this HIE is also related to common emitter configuration. So input impedance generally R is defined as V by I. So here I am going to write RI. R is equal to HIE. So that is relation between V input by I input. So it can be observed under this input characteristics. Hence, it is a ratio of input voltage to the, so means this is the input voltage to the input current with the output is shortened. So in this common emitter configuration, it is a ratio of, so base emitter voltage. What is input voltage? Emitter is a common, what it means that base voltage is represented as VBE to the your input current. That input current is across the base, hence it is represented as IB. So here that is the reason HIE is represented as, it is a ratio of input voltage across the common emitter configuration, that is VBE by, and the common base current, that is base emitter voltage to the base current, that is IB current. So this is defines the HIE. Now similar to that, we need to define reverse voltage gain in a common emitter configuration, that is HRE. So this is reverse voltage gain means it is the reciprocal of the voltage gain. So generally the voltage gain is defined as the ratio of output parameter to the input parameter. Means it is the reciprocal of this one, means it is defined as it is the ratio of input voltage to the input output voltage when the input port is open circuited. So then we need to define this HRE parameter is related to common emitter configuration. If you observe this common emitter configuration, let us say this is the base and the emitter and the collector. So means input is passing through base and emitter. Output is measured with respect to collector to emitter, that is represented as VCE. And what is the input? The input voltage is measured between the base and emitter. Means the potential difference between this base and emitter is represented as VB. Hence, the reverse voltage gain is defined as it is a ratio of input voltage to the output voltage. So in this case, so the input voltage means what is the input voltage? VB by your input current is IE. So this is IB. So that is base. So that is the reason it is defined as it is the ratio of base emitter voltage to the emitter voltage, collector emitter voltage. So it is the ratio of base emitter voltage to the collector emitter voltage with base current is 0. Then so here so this is we need to write output voltage. So is the ratio of input voltage to the output voltage. So output voltage means that is measured between collector to emitter. Hence we need to write VC. So that is the reason. Is the ratio of base emitter voltage, base to emitter voltage to the again collector to emitter voltage. So that is the reason. HR is represented as input voltage is VBE and output voltage is VCE. That is related for common emitter configuration. Now define output impedance of common emitter configuration, that should be represented as HOE. So it is a ratio of, so this is actually output admittance, sorry. So or the reciprocal of admittance is nothing but your impedance. So hence it is a ratio of output current to the output voltage when the input is open. Means we need to write the admittance Y0 is represented as 1 by Z0. So generally we know that the Z0 is it is a ratio of output voltage to the output current. So hence we need to find out that output admittance. So hence Y0, that Y0 is equal to the reciprocal of impedance, that is output current to the output voltage. So that is the reason. Hence it is represented as it is a ratio of output current to the output voltage with input is open. In this common emitter configuration, the ratio of the collector current to the collector emitter voltage with base current is 0, means IB is 0. When IB is 0, we need to find out this admittance parameter, that is HOE. The next one is define stability factor and write that expression. In this case, the stability factor is a rate of change of collector current with respect to the reverse saturation current when the collector to emitter current gain, collector to emitter current gain and the base current is constant. So means that we know that when the reverse voltage is applied, as per your diode equation, I is equal to I naught into e power v by eta times of Vt minus 1, where this Vt is thermal voltage, e power v by So Vt is eta times of Vt. Vt means thermal voltage. So why we need to consider thermal voltage means due to the temperature for every 10 degrees centigrade, the reverse saturation current becomes double. So means even though if you apply the a large voltage when or the transistor is enters into the saturation mode also, then what happens for every 10 degree centigrade, the reverse saturation current becomes double. To stabilize this Q point, then we need to consider some of the important parameters like stability parameters. So in that, the stability factor that should be here represented as is equal to the rate of change of collector current with respect to the rate of change of reverse saturation current. Means we have the three terms. That collector current, if you observe the collector current IC is equal to beta times of IB plus 1 plus beta times of IC naught. So under this condition, let us assume if T is increases, the reverse saturation current is increases. If the reverse saturation current is increases, your input current is also increases. Why? Because of that. So we know that IC is equal to beta times of IB. So if input current is changes also, then the calculated current is also changes. That is the reason. So we need to identify the stability factor, how much the collector current changes with respect to the a reverse saturation current. There, this reverse saturation current is represented as IC naught. So how much collector current is changes with respect to the change of reverse saturation current, that should be measured in your stability factor as S here. Now, what are the advantages of the H parameter model? Why we go for this H parameter model or a small signal model? The hybrid method, we have the two types of advantages. One is the value of circuit components are easily available. Means by using the small signal model, we can observe the circuit components parameters like input impedance, output admittance, like reverse voltage gain and current gain. Then procedure is following quite simple and easy to understand. So means there is no critical paths here. So we can easily understood how to draw this small signal model to identify the analysis of the transistor. Now we'll see what is BJT means, where the BJT abbreviation is Bipolar Junction Transistor. So here the bipolar junction transistor is two PNP diodes are connected back to back. Then it forms a three-layer structure. The three-layer structure contains the three terminals. One is emitter, base, another one is collector. So hence the bipolar junction transistor or a BJT is a semiconductor device that is constructed with three doped semiconductor regions. So that is base, collector and emitter. Now explain the breakdown voltage in a transistor. So what is the meaning of breakdown? If when a large amount of voltage is passing through the semiconductor, and due to that large amount of the breakdown, large amount of the voltage is applied for any semiconductor device or active components, then it destroys the operation of the particular device operation. Means at which point it is in a standby condition, or it allows the maximum moment of the charge carriers to allow the conduction. So hence the current is due to the moment of minority carriers across the junction and its independence of the applied reverse voltage. Here the reverse bias is increased to a large value. The current through the junction increases abruptly. This abrupt increased voltage is known as breakdown voltage. Now, define transistor current. In an NPN transistor, the direction of the conventional current is same as the whole current in a PNP transistor. And in the total transistor current is defined as why, because of that we have the transistor two transistors. One is NPN transistor, another one is PNP transistor. So this is PNP. So for this case, we have the terminal representation: emitter, base, collector. Based on this terminal representation, emitter is always lose the charge carrier or to emit the charge carriers to allow the conduction, and collector is collect the charge carriers from the emitter through the bypassing the base. So that is the reason. And what is the source here? Which one is the give the charge carriers? Emitter gives the charge carriers. And based on the given construction, the only the 5 to 9% or 2 to 5% of the charge carriers, 2 to 5% of charge carriers are moving towards the cutter, and the remaining the 90% charge carriers are reached to the collector. So from that, out of these three terminal representation and the theory of the transistor representation, the only the emitter is always gives the charge carriers. Hence, the how many charge carriers are diffused, then how many charge carriers are produce the current. That should be where the current one is there in a base current, one is there in a collector current. So hence, the emitter current is approximately equal to IC plus IB. So I is equal to IC plus IB. So here it is represented as I is equal to IC plus IB. So hence that is represented as, again, from this representation from the transistor current or transistor construction, we are saying that only the 10% of the charge carriers are reached to the base, and the remaining the 90% of the charge carriers are reached towards the collector. So that is the reason where the base current is a very small compared with the collector current. So due to the construction and to the operation of this one, so hence IP is a much less than of IC. So simply we can write this emitter current is approximately equal to collector current. So hence here I represented as this I is equal to IC parameter. Then define early effect or a base width modulation. So let us consider the transistor construction, and this is p-type material or NPN. Suppose if I take the NPN transistor, this is n-type material. So this is the junction formed. Why? Because the interconnection of the two different materials. Let us take this is P, and this is one more is so this is P, and again this is N. This is depletion region 1, depletion region 2. Let us take this is emitter, this is collector. So here it is represented as base. Now to satisfy the transistor definition, so initially we discussed that it transfers, the transistor means it transfers low resistance input circuit to the high resistance output circuit. Means at the input side we need to offer a low resistance, and output side we need to offer the high resistance. So means we need to offer the input side the low resistance circuit, and output side we need to offer the high resistance output device. Now how we can make this is the input side, how we are going to offer the input side is low resistance and output side is high resistance. If you recall the diode operation, so let us consider if this is the normal PN junction diode. When the PN diode is configured under the forward bias, So means the P is connected to positive pole of the battery, N is connected to negative pole of the battery. We can say that diode is in the forward bias. Similar to that, when diode is connected reverse direction means this is cathode, this is anode. So means here at this point, the cathode is connected to positive pole of the battery and anode is connected to positive, means this anode is connected to negative pole of the battery, means P type is connected to negative pole of the battery, N type is connected to positive pole of the batteries. Then we can say that reverse bias. Now, what happens under the forward bias in a normal PN junction, it offers a maximum current. So, hence, under the forward bias, the bipolar junction transistor offers a maximum current. As per according to resistance, R is equal to so R according to Ohm's law, I is proportional to or inversely proportional to the resistance. So there, according to Ohm's law, I is inversely proportional to resistance. Hence, so here this resistance, what happens here? So we need to make the forward bias input side. Let us take this is emitter. The type of material is N and the base is a P. The B means it is a positive type of material. So let us consider. So now we need to draw the circuit. So what we need to draw here? So first we need to take. So we need to apply the forward bias, means emitter is N type and N means we require the negative charge particulars. For this emitter, we applied a negative charge particular and with respect to base. Similarly, output side, we need to offer high resistance. To offer this one, output side we need to connect the reverse bias. So hence, this is again N and P and N. So for this NPN transistor, so now we need to connect the reverse bias. Means how to connect the reverse bias. So this N should be connected to means reverse voltage of the external source, and with respect to this is already positive. So hence positive is connected to like this, means so means for N type material is connected to positive and P side is connected to negative. So for this case, now we need to make the reverse bias, means N is connected to positive and P is connected to negative. So hence P is connected to negative. At this point, this particular junction is acts as a reverse bias. At this point, the first particular junction is acts as a forward bias. Now, again, if you recall the diode principle, when the diode is under forward bias, then what happens? The depletion width becomes very narrow, and hence the movement of the charge carriers are moving or diffusing from the one region to the another region. And again, as per the principle of the diode, when the diode is a reverse bias, or for this transistor, if this NPN is connected to reverse bias, what happens? It offers a very small resistance, means so it requires a small resistance at the output side due to this our application, and input side it requires the large. So in the variation, the effective at this point. So if you goes on increasing the reverse voltage at the base side, so means what happens? Your depletion width penetrates towards the destination. So if it goes on increasing this one, again depletion width is increases again. So what happened? At a particular point, so this is called as the a potential barrier or deflation width. How this depletion width changes with the variation of the reverse voltage. So if it goes on changing this reverse voltage for this transistor, what happens? That depletion width is very near to the base, or it crosses or it mixes with the base region. So hence. So for this case, what happens here due to increasing of this reverse voltage for an NPN transistor or a PNP transistor, the depletion width of the emitter or the base should be beyond the limit. Means it suppresses the base width dimensions, or it loses the base information. So that type of concept here it is called as the base width modulation. So hence the variation in the effective width, the width will be changed. The effective width of the base in a bipolar junction activity due to a variation in the applied base collector voltage. So only thing is that if you want to identify the reverse voltage, means if you want to identify this a base width modulation, then we need to apply the reverse biasing condition for that output side, means that is base to collector. So in between this base to collector, we need to apply the reverse bias. Due to this approaching of the reverse bias, the depletion width is penetrating or widening. So hence it completely occupies the base region. So that the base width is how the base width will be modified, changes with a variation of the applied voltage. That is called as early effect or a base width modulation. Now we define current amplification factor. So generally, the current amplification factor is nothing but is defined as ratio of the output current to the input current. So hence, the current amplification factor in a BJT is defined as it is a ratio of output current to its input current. Now we have the three configurations like common base configuration, common emitter configuration, common collector configuration. In a common base configuration, that amplification factor is defined as alpha. In a common emitter, that amplification factor is defined as beta. In a common collector, it is defined with gamma. So that is the reason. In a common base configuration, the base is a common. So remaining two terminals, emitter and collector. So at this point, base is a common means emitter is taken as the input and the collector is taken as the output. So that is the reason. It is a ratio of output current means collector, the collector current to the emitter current. So hence in a common base configuration, I defined as this I taken as the example here. So for this case, it is a ratio of collector current to the emitter current. That is defined the amplification factor for common base. Hence alpha is equal to IC by I. Suppose if you want to write the amplification factor for common emitter means beta. So it is the ratio of output current means emitter is a common for base and the collector. Base is for input, collector is output. So hence, so it is defined as IC by input current is base, hence beta is equal to IC by I. For this is common emitter configuration. So similar to that, explain about transistor and amplifier. So based on the configurations and based on the regions of the operation, then the transistor is applicable to some application like switch and amplifier. So here amplifiers means it increases the signal strength. So it improves the signal strength of the output side. That is the reason the transistor, it transfers the low resistance input circuit device to the high resistance output circuit device. So hence here the transistor. So but again similarly when this transistor is acts as a amplifier. So means if the transistor is enters in an active region, then the transistor is acts as a amplifier. When the transistor is enters into the active region, the transistor is acts as amplifier. Now we know that we have the two junctions. One is emitter base junction, another one is collector base junction. So when it is enters into the active region, means emitter base junction is a forward bias, collector base junction is a reverse bias. Now the transistor is enters into the active region. In this active region only, the transistor is acts as a amplifier. So that is the reason. In a transistor, the input, that is PN junction, input means emitter base junction, is a forward bias, and the output junction, that is if it is a common base, like that, output junction. So this is called normally if you want to write this emitter base junction is replaced with the input junction. This collector base junction is replaced with the output junction. So hence, if the input junction is a forward bias and output junction is a reverse bias, then it acts as an amplifier. So means if to satisfy this, the transistor is as an amplifier, we must be operated in an active region. Now, we can say how the transistor acts as a switch means you take the switch means the switch is acts as a on state as well as off state. And if you recall that the modes of operation when the input junction and output junction or emitter base junction are occurring. So if both the junctions are forward bias, now we can say that the region is called as the saturation. If both the junctions are reverse bias, then it is called as cutoff region. Means the cutoff region means the state is represented as off state. The saturation means the state is represented as on state. So mean if you want to work the transistor is acts the switch, we need to define these two modes of operation. Means either on mode, then we need to define off mode. So that is the reason. We need to define saturation mode as well as the cutoff mode. So hence, in a transistor, unless a current flows in the base circuit, there is no current can flow in the collector circuit. So this property to allow a transistor to be used as a switch. Now, what are the various regions in a transistor? So means we have the three different regions. One is defined as cutoff region, one is active region, another one is saturation region. Then relate between IC, IB and beta IC naught in a Bjt. If you observe the one relation, so we know that generally the characteristics expression IC is equal to beta times of IB plus 1 plus beta times of IC naught. The collector current expression in a transistor is a generalized collector current is a representation is beta times of IB plus 1 plus beta times of IC naught, where the beta is amplification factor, current amplification or a current gain, and IB is base current, and IC naught is reverse saturation current when output is open circuited. So that is called as the reverse IC naught is reverse saturation current when output is open circuited. So this is the relation IC is equal to beta times of IB plus 1 plus beta times of IC naught. So that is the reason. And one more is list the terminals in a Bjt. So we know that we have the three terminals in a bipolar junction transistor. One is emitter, base and a collector. So if you observe the emitter, in this case, emitter is always heavily doped and collector is moderately doped, base is very lightly doped. So define the base spreading resistance. So this base spreading resistance observed in a common emitter configuration. The width of the base region extremely very small. So we know that by making the transistor construction, the base region width is very small. Because of that, to diffuse the charge carriers from the emitter to collector, it should be crosses the base. To satisfy the statement, then while doing the transistor construction, they are making that the base width region is a very small. So hence, the resistance offered by this narrow path region is called as the base spreading resistance. Now define leakage current in a transistor. So generally we know that when the leakage current is occurred, when that particular circuit is open circuited or particular device is open circuited or under when it is in a reverse bias condition, it allows leakage current. So N. Again, this leakage current in terms of charge carriers, but the leakage current due to the minor, suppose, let us take a normal PN junction. If it is a reverse bias, so we know this one, this is P and N. The majority charge carriers are holes here and the minority charge carriers are electrons. In the N-type, the majority charge carriers are electrons and the minority charge carriers are holes. So this is for hole representation, this is for electron representation. If it is a reverse bias, so what happens? The charge carrier means the holes are attracting towards the battery, and here the electrons. So here the electrons are attracting towards the battery, holes are attracting towards the bar. This P region also contains a minority charge, that means electron. So this electron, due to this property, electron is diffusing towards N side, and the N side, the minority charge carries the hole. This hole is diffusing towards the P side. So due to this diffusing the charge carriers in the transistor or in normal diode, then it conducts the current. That current is called as here the leakage current. So hence the leakage current is observed with the charge minority charge carriers. Define avalanche breakdown in a transistor. So these breakdowns will be observed when you are applying the reverse voltage or a reverse bias condition. So hence, due to the increase in the reverse voltage, what happens here? The increased amount of energy or minority charge carriers. Then the diffuse means it crosses the junction. As the reverse voltage increases, the further minority current acquires a large amount of energy. As the amount of this one, so what happens here? The reverse current increases rapidly. So that is the reason. This cumulative increases or rapid increases of carrier generation is known as avalanche multiplication or avalanche breakdown condition. Then write the relation between current gain alpha and beta. Means we need to write in terms of this is alpha is a measure in terms of common base. Beta actually should be represented in common. Now I'm going to relate the between alpha and beta. So alpha is represented as beta by 1 plus beta. If you want to write beta in terms of alpha, that is alpha by 1 minus alpha. So hence this is two relations here, alpha and beta. Now what is NPN transistor means? What is the transistor? How to consider transistor? So two PN diodes are connected back to back, then it forms a transistor. So under this construction, NPN means this is this type of connection N, this is P and N. So the P is intermediate between two N type materials. Then this type of the transistor here is called as NPN. This is base, emitter and the collector. Hence it is represented as a bipolar junction transistor formed by a sandwiching this P type semiconductor layer is in between two N type semiconductor layers. That is called as NPN transistor. The symbolic representation is, so this is the symbolic representation of the NPN transistor, and it is collector, emitter, and this is base. Now similar to that, what is PNP transistor means? PNP transistor means again two PN diodes are connected back to back. So this is P and N, this is P. Here this interconnecting medium is base, and here emitter and the collector. So that is the reason. In this case, the bipolar junction transistor formed by sandwiching. Here the N-type material is in between two P-type semiconductor layers. And the symbolic representation of this PNP transistor means the current flow direction inside the transistor. So this is base, collector and emitter. This is PNP transistor. Define forward current gain. HFB means, so forward current gain means it is defined as it is a ratio of output current to the input current. So HFB means this is common base configuration. Common base means emitter is acts as the input, collector is acts as the output. So HFB means forward current. It is a ratio of output current to the input current. So what is the output current? Output current means collector current. Input current is emitter current. So hence HFB is represented as the rate of change of collector current with respect to the rate of change of emitter current. So hence the forward current gain for the common base configuration is defined as the change in collector current. So this is delta IC is divided by the change in emitter current. This is delta I. By making the output voltage is constant. So here we need to maintain output voltage is constant. Now define input impedance HIB means input impedance means R is nothing but a V by I means input voltage to the input current. So for this common base, emitter is acts as the input, collector is acts as the output. Input voltage means so that is voltage between emitter and the base VEB, and input current, that is input current is acts as the I. So hence it is a ratio of input voltage to input current with output is a short circuit. In a common base configuration, the ratio of emitter base voltage, hence this is VEB, to the emitter current, that is VM. So hence HIB is represented as VEB by IE. Now define reverse voltage gain HRB means again HRB. Reverse voltage gain means it is the ratio of input voltage to the output voltage VI by V0, and in common base configuration means so in CB common base configuration, emitter is acts as the input terminal, collector is acts as the output. So input voltage means that is VEB, output voltage means that is through VCB. So hence the HRB is represented as it is the ratio of input voltage, that is emitter to base voltage to the collector to base voltage. So hence it is defined as it is the ratio of emitter to base voltage to the collector to base voltage when the emitter current is 0. Now similar to that, we need to define output impedance. So actually this is the output admittance HOB, or the reciprocal of impedance, why not? So HO means output admittance means actually the impedance means Y naught means output voltage to the output current V naught by I naught, but here we need to write output current to the output voltage. So that is the reason. In this again HOB means in a common base, again we know that emitter is acts as the input terminal, collector is acts as the output terminal. So output current means collector current, then output voltage is nothing but your VCB. So that is the reason. In a common base configuration, it is a ratio of collector current to the collector base voltage. So hence HOB is represented as the rate of change of collector current with respect to the rate of change of collector to base voltage. Now similar to that, then we need to define the forward current gain in HFC. So means the forward current gain in common collector configuration. So in a common collector configuration, we know that the base is acts as the input and emitter is acts as the output. Now we know that the forward current gain means it is the ratio of output current means emitter current means the rate of change of emitter current to the rate of change of input current, that is base current, that is IB. Hence it is defined as, so in a common collector configuration, it is defined as the emitter current is divided by the change in base current by making this voltage is constant. Now similar to that, we need to find out the input impedance HIC and common collector. So again in a common collector, base is the input terminal and emitter is output terminal. Input impedance means HIC or RI, that is equal to input voltage to the input current. So what is the input voltage? Input terminal acts as the base means that input voltage is passing through base to collector VBC. So means VBC to the input current, that is input is a base, that is nothing but your IB. So that is the reason. It is defined as it is a ratio of base to collector voltage, that is nothing but a VBC to the base current, that is base current is IB. Now similarly, we need to define reverse voltage gain HRC, that is HRC nothing but is a ratio of input voltage to the output voltage. So in a common collector configuration again, so base is input terminal and emitter is output terminal. So for this case, what is the base? So we required input voltage means base to collector, VBC means VBC. Output voltage means emitter. So emitter to collector, that is emitter to collector voltage. So hence it is a ratio of base to collector voltage to the emitter to collector voltage, where your input current is 0. And similarly here we need to find out output admittance. This is so HOC. So here again HOC is defined as it is a ratio of output current. So output current to the your input output voltage. So what is output current here? Emitter is acts as output current. So hence it is a ratio of emitter current, that is IA to the, so output voltage is emitter to collector voltage, that is VEC. Now, what is the input characteristics of BJT? Means this characteristic shows that the relation between the input parameters, that is input current and the input voltage for a given output voltage. So that is the reason. The curve that gives the relationship between the input current and input voltage for a given output voltage for a given input current of a transistor. Now, similar to that, what is the output characteristics of BJT? So this shows that the relationship between the output parameters, that is current and voltage for a given specifications. So hence up to this point, today we discussed that some of the definitions and terminology on the module 2, that is bipolar junction transistor. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.